Good afternoon, my dear students. Today I am going to explain decimation in time algorithm. Decimation in time algorithm. As we know that in an FFT we have two algorithms. Among those two, one of the algorithm is decimation in time algorithm. DIT FFT algorithm. Here, which is also called as radix to FFT algorithm, also called radix to FFT algorithm. Radix to FFT algorithm, which means the number of output points n can be expressed, the number of points number of output points n can be expressed as a power of 2, that is capital N is equal to power m, where m is an integer. M is an integer. Okay, so now let us consider x of n sequence. Let us consider x of n sequence whose length is n points, mainly in DIT FFT algorithm, not only in DIT FFT algorithm, either it DIT or DFT, that is a decimation in time or decimation in frequency FFT algorithms, we are going to divide the input sequence into even samples and odd samples. So that is the reason we can call it as a fast Fourier transform compared to the DFT, to reduce the computational complexities. What are the computational complexities? Here the computational complexities means complex number of additions and complex number of multiplications. Okay, so let us consider an x of n whose length is n points. So that x of n sequence is divided into xe of n and xo of n, where xe means even sequence of x of n and odd sequence of x of n. Okay, we know that DFT equation. What is that? For an x of n input sequence, for example here it is a DFT. Let us consider we are going to apply the DFT to the input sequence x of n. What we will get? We will get x of k. In similar way, so whenever we are going to divide input sequence x of n into xe of n plus x naught of n, we will get the output according to the DIT FFT algorithm. We will get the output x of k is equal to xe of k plus twiddle factor. Here the twiddle factor is represented by w suffix n power k into x, capital X of O of k. We know that capital X of k is a DFT output. So by applying a DFT to the even and odd sequences of input sequence, we will get the output this one. Okay, let us write down the known equation for the DFT. Capital X of small k is equal to summation n is equal to 0 to capital N minus 1 x of n into e to the power of minus j 2 pi n k by capital N, where k range, where k is equal 0 comma 1 comma 2 comma and so on to n minus 1. Now let us write down this in terms of xe of n and xo of n, that is even sequence and odd sequence. First of all, let us write down xe of n, whose length. After then we are going to apply DFT to that. xe of n is, you know that an even function is represented, that is x of 2n. Okay, let us write down that x of 2n, where a small n values 0 comma 1 comma 2 comma and so on to n by 2 minus 1. Likewise, odd sequence of x of n, that is x of 2n plus 1. Here also the n range from 0 comma 1 comma 2 comma and so on to n by 2 minus 1. Now let us write down once again a DFT equation, and that is x of k is equal to summation n is equal to 0 to capital N minus 1 x of n into e to the power of minus j 2 pi n k by capital N. So in which whatever we have the exponential term, in this case we are going to write it as w suffix n, that is, which is also written as summation n is equal to 0 to capital N minus 1 x of n into w suffix n power n into k. By here, since w suffix n power k is equal to e to the power of minus j 2 pi k by capital N. Okay, let us write down overall this entire equation. That is, now we are going to separate this input sequence x of n into even and odd. Okay, for that, summation n is equal to 0 to n minus 1 x of n into e to the power of minus j 2 pi n k by capital N plus summation n is equal to 0 to n minus 1 x of n into e to the power of minus j 2 pi n k by capital N. సో ఇప్పుడు దీన్ని నేను ఎట్లా రైట్ చేయాలనుకుంటున్నాను, ఈవెన్, ఇక్కడ ఆడ్. సో ఈవెన్ ఆడ్ అని చెప్తే here already we have written what we have written here, n range from 0 to n by 2 minus 1, and in place of x of n for even we are going to write it as x of 2n. Okay, so summation n is equal to 0 to n by 2 minus 1 x of 2n into, so in place of this what we are going to write, w suffix n power, so at which we have the n, in place of that we are going to write as 2n. Okay, plus summation n is equal to 0 to n by 2 minus 1 x of 2n plus 1 into w suffix n power, at which we have the n, we are going to substitute in place of n, we are going to substitute 2n plus 1, that is 2n plus 1 into nk. Okay, now let us simplify this second part, that is odd sequence. It is an even sequence of input, and this one is odd sequence of input, odd. Let us simplify that. Summation n is equal to 0 to n by 2 minus 1 x of 2n w suffix n power 2nk plus, దీన్ని సింప్లిఫై ఎట్లా చేయొచ్చు, సమ్మేషన్ n is equal to 0 to n by 2 minus 1 x of 2n plus 1, సో దీన్ని ఎట్లా రాసుకోవచ్చు, w suffix n power 2nk into w suffix n power nk. ఇప్పుడు ఈ w suffix n power nk ని ముందు తెచ్చేస్తే summation n is equal to 0 to n by 2 minus 1 x of 2n w suffix n power 2nk plus w suffix n power nk summation n is equal to 0 to n by 2 minus 1 into x of 2n plus 1 w suffix n power 2nk. Now let us simplify this entire one, at which we have the, we know that, what we know that w suffix n power k is equal to, what we have, e to the power of minus j 2 pi k by n. If we have w suffix n power 2nk, then which is e power minus j 2 pi nk by n, and here we are going to mention the square, so we are going to take the square for this. Okay, which is equal to w suffix n power n by 2 power k. Simply we can write it as here. Okay, so now let us simplify this above one. How we are going to simplify that? Therefore wait a minute. So let us simplify this step. Therefore summation n is equal to 0 to n by 2 minus 1 x of 2n into ఇప్పుడు దీన్ని ఎట్లా రాసుకోవచ్చు, w సఫిక్స్ n by 2 power nk plus w suffix n power nk summation n is equal to 0 to n by 2 minus 1 x of 2n plus 1 into w suffix n by 2 power nk. That is, it is even and this one is odd. For what is the length of this n by 2? 0 to n by 2 minus 1 means n by 2. That is, it is n by 2 length of even sequence of x of n, and this one is n by 2 length of odd sequence of x of n. So what it indicates, it indicates DFT, that is n by 2 length of DFT of even sequence, n by 2 length of DFT of input sequence, DFT of input sequence. Input sequence ని ఎట్లా డివైడ్ చేసాం, ఈవెన్ సీక్వెన్స్ అండ్ ఆడ్ సీక్వెన్స్, దట్ ఈస్ ఎక్సీ ఆఫ్ ఎన్ అని చెప్పుకోవచ్చు. ఇక్కడికి వచ్చేసరికి n by 2 length of DFT of odd sequence, n by 2 length of DFT of even input sequence, this one, and this one is DFT of odd input sequence. How we are going to mention that odd input sequence? XO of n. Okay, so finally in this place we are going to write it as here. What we are going to write? We are going to write capital XC of k, and here plus, and already we have w suffix n power nk into, and in this place we are going to write as DFT of odd sequence, that is x naught of k, that is x of k. It is very, very important. Why? Because while drawing butterfly diagram, so we are going to take this formula only. Thank you.